So we're looking at the chapter review homework. I'm going to start it with number 5. So here we're just trying to tell whether the function represents exponential growth or exponential decay. So for these ones, this is the 4x4 grid that I showed you. If the b value, here we have a b value, so I'm going to just represent the information that I care about. So here, the thing that I'm noting is that my b value is less than 1, and you can put between 0 and 1 if you want, but I always talk about it as less than 1 because we know our b value needs to be positive for these. So I got a b value that's between 0 and 1, and my exponent for the x is positive. So if this thing is small and there's a positive exponent, that makes this one decay. So the grid that I set up for this one looks like we've got our b value stuff here. We have our exponent stuff here. Here I'm going to put exponent as positive and negative, and we'll put our b value as less than 1, and we'll put our b value as greater than 1. So if my b value is less than 1, so I don't know, I'll put this in like a box and we'll circle these things. So if my b value is less than 1 with the negative exponent, that's going to make this thing growth. If it's less than 1 with a positive exponent, that's going to make it decay. If I have bigger than 1, so like 3, 4, 5, but a negative exponent, that's going to make this thing decay. Bigger than 1, but positive exponent, that's going to make this growth. So when we look at this one, we see this is decay right here, are less than 1 and positive. So basically this little chunk right here. For number 7, do 7 in green here, we have a b value, which is greater than 1. So the a value doesn't matter at all. So this like 3 out in front, I mean, these things are supposed to be positive for growth or decay, so just keep in mind that it'll look positive, but the b value is the one right here being raised to an exponent. It's being raised to a negative exponent. So now this one is decay as well. So since I have a value greater than 1 and it's to a negative exponent, then here we see I have decay as well. So this was my second one, and this was my first one here. Any questions on either of those? Perfect. Let's take a peek at expanding these expressions. So when we're looking to expand, I'm looking to say, okay, well, what's happening on the inside of this log thing? So inside this log, I have 6, an x, and a y, and they're all being multiplied. So I need to think of what my product property for logs is, and that's going to be addition, right? So if I had log base 3 of, and now we can start splitting this thing out. So you can really do it all in one step here, or you can break it out. But how do we get 6? We get 6 from 2 times 3, right? So here I would have log base 2 plus, and here I'm going to do log base 3 of 3, whoops. And then I got plus, and now here I'm going to have log base 3 of x plus log base 3 of y. So the one thing I want to do, make sure like at the end of a problem, once you've like quote unquote fully expanded it, is you check to make sure anything can be simplified or not. So log base 3 of 3 is just 1. So my final answer here should look like 1 plus, and then all this stuff up here. So my log base, I'm feeling lazy, that, and it's not lazy, it's just clever, right? I mean, why copy this stuff when we can make the computer do it for us? So this would be my final answer here. So again, 6 being 2 times 3, and then times x times y. Here we go. This is fully expanded and simplified right here. Any questions on this one? Perfect. Let's do the next one in green here. This one's slightly more interesting because it has one additional step. So now for this one, as I'm looking at this, it's log 5x to the third. So when I'm looking at this, 2 ways you can look at it. I'm going to personally drive it in one direction, but it's not wrong for you to like split the whole thing out, because really what's going on here, it's 5 times x times x times x. So if you want to do it that way, totally fine. I'm just going to use my exponent rule. So I'm going to break this down into 2 steps basically. So I'm going to say I have log, Since I don't see a base, I know my base is 10. That's my common log. So I'm going to just say this is log 5 plus log x to the third. And I want to keep expanding this thing, so my third here is going to come out in front. And so this is actually going to become log 5 plus 3 log x. And I'm done. So I think, like, I don't know, I've only seen it a couple times, but some people get a little bit confused here and they say, okay, well, isn't it better to have log x plus log x plus log x? And I understand why people think of it that way, but when we have multiples like that, we'll just collect them together and call it 3 log x. So this would be the fully expanded version. Any questions on either of these?
For number 25, how can we put a plus, like 1 plus in front of it?
Because this chunk right here became my 1. So log base 3 of 3 is 1.
Oh, I see.
Yeah, good question. So if this was like log base 3 of 9, it would have been like a 2. Or you could have thought of it as 3 squared, 2 out in front, 2 times 1, that would make 2. So just simplifying there. Good question. Let's look at the next one here. Looking at 33. So here we want to solve, and then make sure you check for extraneous solutions. So again, the biggest extraneous solutions that will come from problems like this are going to be when I'm trying to do some sort of like log thing to a 0 or negative number. So just keep that in mind. So here I want to just make sure this is going to be real by plugging it in at the end, and let's start. So the first thing I would do is I want to get like this thing by itself, right? The 3e to the negative x. So to do that, I would say I'm going to add 4 to both sides. So I'm going to add 4, now I get 3e to the negative x, not my best e, equal to 13. And now here I want to make sure I get the e to the negative x by itself, so I'm going to divide by 3, divide by 3. So now I have e to the negative x equals 13 over 3. From here, I want to get this thing like gone, the e gone, so I want to get x by itself. To do that, I'm going to take the natural log. So if I take the natural log of an e thing, it's going to just give me that thing itself, right? Whatever the exponent is. So natural log of both sides is going to give me negative x equals natural log of 13 over 3. And my last step here is just going to be divide by negative 1. Or you can think about it as multiply by negative 1. And so my final answer will be, I don't know where to write it right here. X equals negative natural log of 13, whoops, over 3. So to test that, you can plug it back in, and you can plug it in exactly like this. So when you do that, we're basically going to see that this all drops off. We're going to end up getting, whatever, like 3 times what, 5/3 here. And when we subtract 4, we'll bring us back to 9, or 13 thirds, excuse me. Then when we subtract 9, we'll get 9. So subtract 4, we'll get 9. Jeez, talking's hard. Any questions on this one? Cool. Look at the last one here. So for 35, here I have 5 log of this thing, and I don't see a base. So keep in mind that my base here is going to be 10, common log, equals 11. So the first thing I want to do is divide by 5 on both sides to get this thing by itself. So now I got log of x minus 2, oops, equals 11/5. From here, I want to get this thing by itself. So how do I do that? I exponentiate both sides. So again, if you want to think about this as like, oh, I just go from log form to exponent form, that's totally fine. Again, we're doing the same thing, but I will describe it like this because this is usually how it clicks for people. So I'm going to do 10 raised to this thing and 10 raised to this thing. And the reason, again, that I'm doing that is so that I can get rid of this log base 10 thing, right? The bases match up. So here on the left side, I'm going to get x minus 2, and then equals 10 to the 11/5, whatever that is. And now as I look at this, I'm just going to say, okay, plus 2 on both sides. I didn't really have to write that in parentheses, but whatever. So now I get x equals 2 plus 10 to the 11/5. And when I look at this, plug it back in, it works, and I'm good to go. Any questions on this one? Oops, there we go.
On a test, would you like, if we have like a question like that, would you like us just to leave the answer like that, or should we like do like the math out like further?
There's no further math to do. So this is fully simplified. This is a good answer.
Okay.
Good question. Good to go. All right.